All right. Good evening. So, let me ask you this before we started. What do you know about quantum physics?
Very little. Nothing.
Nothing? Anybody? No? Nothing?
Very little.
Very little?
A little.
Vicky, do you know anything?
About?
Quantum physics.
I do.
Okay, what is that you know?
It is the very small part of the mathematics.
Uh-huh.
Is like is I know what name, but the word's not coming to my mind now. It's like nanotechnology. I think it's something about it.
Okay.
So the little that I know is that it's based on the fact that when you look at the smallest particles of matter, that there's still more space than solidity in those smallest particles of matter, and that they are moving, and that their capacity to move can be manipulated through quantum physics. That's all that.
Do you know anything about it, Roberta?
Quantum physics?
Yeah.
I know a little bit about quantum and physics. You know, I know that how do I explain right now? I'm a little off my mind, but you know, I practice quantum healing regression, which is
Yes.
when you are able to change in a cellular level. You are able to, when you reach the quantum, you are able to, and the person is in a trance, the person is able to heal themselves because they are in that quantum. They reach that most, you know, that cellular level, and they're able to change in there.
Got
And
it.
that's-
But
yeah.
we're talking about quantum physics. You know physics, right, that we learn at school?
Yeah.
There is a part of physics that is called quantum physics. Okay? And it's kind of like a branch of physics. And let me put a definition here so we'll start it from the definition, okay? So quantum physics, also known as quantum mechanics, okay? It's a branch of physics that deals with the behavior of matter and energy at the smaller scales. At this level, the classical laws of physics that govern our everyday lives breaks down, and a whole new set of rules emerges. These rules, based on the principle of quantum theory, describe the strange and often counterintuitive behavior of particles and waves.
Is it where they prove that the past, present, and future are equal?
There is a lot of theories
Yeah.
inside of quantum physics. But what we need to know is that quantum physics is the study of the subatomic world, meaning that the very small particle seems to behave differently than what we expected. So let's see, for example, law of regular physics. So if I take a tennis ball and I do this, okay, no matter how many times I will do it, as long as I'm hitting the same spot with the same force, I will always get the same results. So the law of cause and effects in physics is what? If I hit this one here, depending on the amount of force that I have, it will break my hand. So the law of physics is what governs our world here, but in the let me see this, in the bigger size scale. But when it comes to particles, they behave completely different, and they behave unexpectedly. And that's what we have to understand in order to see what quantum physics is the understanding. Scientists are trying to understanding how electrons behave, how atoms behave. Isn't it that interesting? So we know how certain elements behave, but we are finding out right now how molecules behaves, how electrons behaves, and that is fascinating. So quantum physics is the study of that. Okay, so the first thing they did, it was to put it up under the microscope, and they saw a little molecule, and one of the things that they were able to see is that that molecule would appear in one side and then disappear and appear there, and then appear here and appear there. So they go, whoa, 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 whoa. What is going on right there? Okay? So for us to understand what is quantum physics, we say it's the behavior of matter and energy at the smaller scales. This is what it is, yes.
So that does align with what I said then?
Yeah.
Okay.
Mm-hmm. There was no wrong answer. It was great. So there is this still physics that govern our everyday lives that breaks down and a whole new set of rules emerges. That is fascinating. So how does a molecule behaves, okay? Let's go in this and let me see this. So one of the things that it's wonderful is this. One of the fundamental principles of quantum physics is the wave-particle duality. According to this principle, particles such as electrons or protons can exhibit both wave-like and particle-like behaviors. This means that they can exist in multiple states simultaneously, a concept known as superposition. It's as if these particles are capable of being in two or more places at once. So I was trying to explain this, and I was like, you know what, I'm going to find a video. Luigi, can you prepare the video? Because the video has graphics and can explain to us what it is. So let's watch this video. And but the main thing that I want you guys to pay attention in this video is this duality. Wave-like and particle-like behavior, okay? So let's go. Luigi, are you ready? It's not a long video, it's a very small video. Okay, so let's go from there because he shows graphics and he will explain much better than me.
I'm going to explain to you what's known as the central mystery of quantum mechanics. It was Richard Feynman, the American physicist, said, this is the central mystery of quantum mechanics. There's lots of weird stuff that goes on in the quantum world. Hit you with this, and it basically tells you what it's all about. It's called the two-slit experiment. I'll start with this. Imagine you have a source of light shining against a screen with two slits. Now, for the pedants in the audience, this source of light has to be monochromatic light of a particular wavelength. Well, whereas, of course, a light bulb is white light, and that's made up of all the colors of the spectrum, lots of different wavelengths. But imagine this is just a single wavelength of light, and you can see the light is coming out in waves like ripples in a pond. That's the nature of wave-like behavior. As the light hits the screen, it squeezes through the two slits, and each slit in turn on the other side becomes almost like a new source of light, and the light spreads out, it diffracts. And as the waves of light overlap, they will interfere with each other. So where a crest hits a trough, they will cancel. Where a crest hits a crest, they will amplify, and so on. And so on the back screen, you end up with what's called an interference pattern. a series of light and dark fringes where the waves have either cancelled out or worked together in phase. That's fine, that's not quantum mechanics, that's a property of light that goes back over 200 years that we've known about since the early 19th century. Imagine doing the same experiment again, but doing it not with waves, but with particles. Do it with grains of sand. So this is the same experiment, but I've tipped it 90 degrees. Rather than waves that are spread out that wash up against the two slits and squeeze through, here you've got individual particles of sand, and each particle will either go through one slit or the other. And so you see they will sort of drain through, and you get two bumps underneath each of the slits. So the two peaks is reminiscent of particle-like behavior, whereas the multiple pattern of interference is wave-like behavior. What if we do the same experiment with atoms? Well, so imagine we have an atom gun, something that can fire atoms, a stream of atoms. You can't see them because they're very small. Let's block off one of the two slits. So these two slits are you know, the dimensions and separation of the slits is chosen appropriately to show us how atoms do things. And so far so good, nothing strange here. You'll see a lot of atoms hitting the back screen. So this will now have to be some sort of photosensitive screen whereby when an atom hits it, it'll give off a little flash of light to say the atom has arrived here. So the atoms are arriving as these little pinpricks of light that we see. Of course, a lot of the atoms will be blocked by the first screen. They won't go through that slit. But those that do get through to the other side, and you can see there's a bit of spreading of the atoms. But if we didn't know anything about atoms, we'd say, well, that's fine, we can understand that. A lot of the atoms are going clean through the slit. Some are sort of maybe bouncing off the edge of the slit, and so they're sort of being deflected a bit, which is why you get a bit of a spread. The first mystery of quantum mechanics comes when we open the second slit. Because now we see something that's very much like the interference pattern we got with light. Rather than having two bands of spots where the atoms have gone through the two slits, it's as though the atoms have gone through the slits behaving like waves, and you get interference of the waves and you get these bands. If we know nothing about atoms or quantum mechanics, you could try and rationalize it and say, well, you know, maybe atoms behave in a very strange way, and only a certain number of them are allowed to all sit together. And so, you know, me and my gang, we're all going to go on this slit. No, sorry, no room for you. You go the next slit above. And by the way, there's this rule that no one can go in between the two bands, but a few naughty atoms do. So there's a bit of a scatter. You know, we don't. There could be some forces between atoms that make them coordinate their actions in a way to give this pattern. That's not mysterious. That's just, we just don't know how atoms do things. But we can be clever, and we can force the issue. What if we were to not send the atoms all through at once, but send them through one at a time? Leave enough of a gap for the atom to get through to hit the screen. Of course, as I say, some atoms will hit the first screen and not get through, but those that get through will hit the back screen. So let's run the experiment again slowly, and gradually you'll see as the atoms go through, they'll look like they're just randomly arriving on the other side. You keep sending atoms through one at a time, and gradually that same pattern appears. So each atom by itself is somehow contributing its small part to the overall wave-like behavior that we see in the interference pattern. How does it do it? How does, we know the atom's a tiny localized particle, we can't see it, it's too small to even see under a microscope, we're firing it at the screen with the two slits. Some moment later you see a flash of light on the back screen. It's arrived in a localized point, it's not spread itself out. You don't get sort of like a wash of a faint light across the whole screen. It's a little point, the atom is localized, it's arrived in a certain location. And yet, it somehow seems to have been aware of there being two slits, not one, because it's given rise to this interference pattern. How does one atom do that? Does it split in half? Does it become like a cloud that goes through both? Well, we can try and be even cleverer. What if we were to spy on the atom and see where it goes? We can gently just observe which slit it goes through. So you put a detector just above the upper slit that will flash or beep whenever it sees an atom go through that top slit. Sure enough, you fire the atoms through, one at a time. 50% of the time, the detector will beep. The other 50% of the time it doesn't, the assumption being that the atom has gone through the lower slit. But of course, I've been cheeky here. I haven't shown you the results of the experiment. That's what you get. 50% of the time, it beeps, and you see a spot arrive adjacent to the upper slit. The other half of the time, it doesn't beep, but you see a spot arrive at the lower slit. So, yeah, it's picked out the atoms that have gone through the upper slit, and not the ones that have gone through. So each atom does go through one slit or the other. But that's a different result to what we had earlier. So here's the last bit of sneakiness that we can play with atoms. Surely now, you know, we're going to get to grips with it. Leave the detector there, but just very quietly go and unplug it. Don't let the atoms know that you're not spying on them. Make them think that you're still detecting them. So, yeah, okay, we're going to run the experiment. Atoms, okay, get ready, one at a time. We're going to be checking on you. All right, so run the experiment again. Now, if you can explain this using common sense and logic, do let me know, because there's a Nobel Prize for you. Quantum entanglement is the idea that particles, however far apart they are, still somehow their fates remain.
You guys get it? Put the lights on for us. You guys get it? No? Kind of? No? Oh, okay.
It's very complex.
It's very complex. Okay, so let me try. Now that you saw the image, we'll try to explain. So what they saw is the atoms was behaving differently according to, there is an observer. You see, when the camera was on, observing, they will act and they will behave as a wave. What this means, that's why you saw, even though there was only 2 little slots to the atoms to go there, they behave like a wave. And then you saw the patterns of atoms on the screen all over the place, just like what happens when you do it with light. Okay? So if you put a light in that, you see there is more light there, less light here. So more light, less light, more light, less light. And we will create a behavior, an effect. This is what I'm trying to explain to you. So you shoot the atoms, and there is too little space for them to go through. And, of course, they're supposed to show up exactly what the space was. That's regularly, right? So the first experiment, what they saw, it was like, well, hold on. How are they behaving? How come there was only 2 slits to pass, and there was atoms all over the place? Do you guys see this? Is that okay? Everybody got it as? Okay. So that was okay. So they say, what's going on? Let me try to record it. Let me try to observe this behavior. And when they did, when they observe, what happens? It behaves completely different. It doesn't behave as a wave anymore. It only behaves as a particle. Remember the first example we gave on the sand? Of course, if it's 2 slats and the particles are coming in, it's going to form 2 little sacks of sand, according to the hole that it was in.
My question is, did they behave differently? I know they behave differently because one of them you were observing, the other one they weren't being observed.
Yes. So
But
when
what-
somebody was observed, it behaved like particle. And when it was not observed,
What kind of observation? Is it maybe the eye? Is it energy? Do you think?
that's what I'm saying.
Yeah.
When they try to observe,
Okay.
they were actually trying to observe, which they were paying attention.
Yeah.
So that means that if you are paying attention to something, it behaves one way. If you're not paying attention, it behaves a completely different way.
That's what I thought.
The energy.
Energy. Yeah.
Not the energy, guys. This is not energy. This is particles. This is atoms.
But they are behaving differently.
They
because
behave.
of-
That's what I'm saying. They are behaving different because of the observer. Okay? So the observer, it could be anything. The observer could be consciousness. It could be awareness. So when the consciousness, when something is observing, now this is how molecules behaves. Isn't it that simply amazing? So that's when everybody's going crazy on a quantum physics, because they will go, what? That means that if I'm observing, it behaves in one way, and if I don't observe, it behaves completely different. What is going on? So the first thing we have to understand is that with this study, we cannot analyze the world with logic, not this logic that we are used to it. This logic that we are used to it, it's good for things here, our size, you know? But when it comes to something else, this logic does not work. The behavior, it's completely different. So what we have as logic is intellectual ideas based on this big world that we see around us. When it comes to something smaller, everything changes. Everything changes. And did you see what he says? He said, if you can explain that, you get the Nobel Prize. That was his last word there. Because with this logic, you cannot explain why a molecule behaves differently. And think about this. The fact that electrons can behave as wave and can behave as particle. That's another amazing thing. What do you mean? Sometimes you a wave, sometimes you a particle. It's just like they did the same experience when they were trying to observe light. You try to observe light that it's one color, you can see that light, it's wave. You see, oh, light, it's wave. That goes from one place. But when you put a light on a very dark object and you cover everything and you put a camera and you try to observe, it becomes particle. It's no longer a wave. How is that possible? How is that possible? So, another mind-boggling concept in quantum physics is entanglement. When two particles become entangled, the property becomes intertwined in such a way that the state of one particle is instantly correlated with the state of another, regardless of the distance between them. This phenomenon, famously called spooky action at distance, this is Albert Einstein who gave this name, challenged a classical understanding of cause and effect. So what do they know today? This is what they know. if you take a particle that was entangled, if you take one particle here, and you take that particle, and you take another particle and put it in Andromeda, it means in another galaxy, not even this galaxy, okay? When you do something to the particle that it's here on Earth, immediately you get the effect on a particle in Andromeda. Andromeda. How is that possible? I want to hear from you. How can we explain that?
Energy travels faster than light.
Okay, do you think it travels? That's the biggest question. Because it's the question, the bigger thing here is simultaneous. Simultaneous. From one distance to, how long would it take if you want to travel to Andromeda? How long?
40 million years.
This is, think about it. I'm not talking about our galaxy. I'm not talking about the particle being in here, one here and one in Mars. One here and one in Jupiter. No, I'm talking about in another galaxy.
So maybe it's an intelligent principle that already know how to be in both places already.
Okay. What else? What is that to come to your mind? How can you explain that? Go ahead.
What comes to my mind is that it's like the cell. We have the matrix cell when it's divided by mitosis. All the other cells have the same matrix, the same, I would say, molecules, the same, but it comes from one. So they are all one, regardless of being separated, of being,
Okay. What else? Who wants to put their thoughts here? Who wants to put their thoughts here? What are you thinking? Come on, go ahead. Go ahead.
I'm going to put a little bit of God in this.
That's okay. Let's.
Because if God or everything, okay, we expect He can act the way He wants.
Okay.
Because He is in everything.
Okay. Who is God?
Nobody has this answer.
Okay. So.
Nobody has this answer.
Okay. All right. So let's go from there. This is the way. This is where our mind needs to go. And we are living our lives instead of trying to ask these questions. The way we live our lives today is, I'm going to eat, I'm going to work, I'm going to, I don't know, do whatever everybody does. Be angry in traffic. This is, and my thoughts are the same thoughts that I thought yesterday, and it's 100% related to matter, related to this world here, that what was going on, that we can actually see, when there is wonderful things that we should be talking about, that we should be at least thinking about, to create new pathways, for us to go in and say, wow, what is this all about? Okay? And when you think about entanglement, when you think about this quantum physics, it's very easy to explain, not for us, but when you look at somebody that actually study spirituality, what are they going to say? They're going to say what? What is the main thing of their belief system? We are everything. Okay? So it doesn't travel to Andromeda. It is there already. And here at the same time. And this is just a particle. Now bring this to your life. What are you? bunch of particles. You are made with the same material. So when you say that God is everywhere, and when they say God is within you, where are you? Everywhere. But you're not the observer, you don't have the awareness of that. You know why? Because we're way too busy living this material life. We're way too busy going into a psychological drama of the everyday life, of traumas and dramas and stuff that we disconnect. You can call this divine, you can call this God, you can call this creation, you can call this, but the thing is that the universe and us, what quantum physics is saying right now, and what they are trying to understand is that it was only one particle. And that particle can go anywhere. Can go, no, it is everywhere. So with that, there is no such a thing as someplace. We don't have to travel anywhere. We're that already. I know it's a difficult process. I know it's a difficult thing to understand. But this is what it is. It's everywhere and nowhere. Those are two realities. Everywhere and nowhere. But there is no such a thing as somewhere. This is what these incredible studies are showing us. That we are much more than what we think. Look at this, look at memory, for an example. We have today a completely different idea of memories. You know why? Because before, maybe what, 40 years ago, you would say the memory is something that it's within you. It's in my head, it's memory, right? But now look at this. Memory, it's on a cell phone. Memory, it's on your computer. Memory, it's in a lot of places. So look how we switch and we go, hold on, what is memory? Memory is not only something that I have, that it's in here. Because a smartphone has memories. So memory can be outside of me. You see the switch, how we can change? Now that we know, and we also know the water has memory now. Wow, water has memory. So what else has memory? Does the air have memory? What is memory? So remember this. We have to be able to go from one way of thinking to another. We do that all the time as a generation, but we can also do this as a human being. Okay, we can also do that. So when Jesus on the gospel says this, not even one leaf of a tree goes on the floor without me knowing. How do you interpret this? With my father, he said God. How do you interpret this with this new way of thinking? Of course, what is the tree?
Everything is
Everything. So I was talking to an entity one day, and he told me that something. He said to me that I'm everywhere. I was like, what do you mean everywhere? I'm looking for places, you know? This is my mind. Our mind works that way. So when he told me I'm everywhere, I was like, well, everywhere. What is this? And the way that he spoke to me was so poetic. I'm having a hard time trying to grasp the idea. And then he's telling me, listen, not every word use your technology. You have your own technology. And some words up there, they develop without using smartphones. So he was trying to explain to me, I'm everywhere. And I was like, oh, how? So that means that if I wanted to call my mom in Brazil, I could develop that capability to do that without a smartphone? Oh, yeah. Do you have a natural technology in us? The problem is that we are so dependent on technology outside of us that, of course, we're not going to develop anything that we already have, that we already put all our money on the outside technology, and then we don't develop these wonderful capabilities that we do have as divine.
And the problem, I think, is that we don't even know we have that ability and that we can access. We don't believe it.
Exactly.
It's like, no, I don't, no.
Exactly. Because you are you identify yourself only as, this body and this name. That's all. That's all we think it is. And we are way too separate. You are me, you are you. So this division, it's something that, that also plays a role in how we perceive the universe. So one of the most iconic thought experiments in quantum physics, this is wonderful. Okay, this is going to blow your mind. It's Skrondova's cat. Imagine a cat locked in a box with a vial of poison that could be released by a quantum effect, such as decay of a radioactive atom. According to quantum theory, until the box is opened and observed, the cat exists in a superposition of being both alive and dead simultaneously. It's only when we make an observation that the cat chooses one of these states. Imagine that. So now we question, what is real? And what is not real?
an illusion.
See? We can start to think about, I don't have the answer for you, but how can this be? So you have a cat that was inside of the box, and this box has a vial of poison that could be released by a quantum event. So the poison is there, and it could be active by light or anything that will kill the cat. So what is this? A possibility. But the cat is there. Before we open the box, the cat is alive and dead at the same time.
Depending on.
At the same time. But if we open the box, then it's going to be one or the other. What is it? So let's go. I'm only here to confuse you, okay? Nothing else.
Good job.
I'm only here to confuse you. Okay, right? So let's go here. This is, we have to start questioning ourselves. And this is not Spiritism, this is science. This is quantum physics.
But science is spiritism.
For some branch, for some yes, for some no. But this is science. This is even worse. I'm not talking to you about something that a spirit wrote and brought this. No, this is science, okay? So in conclusion, quantum physics is a captivating realm that challenges our intuition and expands our understanding of the universe. Why intuition? Why? Because with logic, it won't happen. Even they know this. Because if they're going to apply the logic, it doesn't apply to this universe. It doesn't. How does the string theory started? When they were seeing that the molecules was changing, the particles was one here, one time here, one there, one time here, one there, one time here, one there. So they came up with the string theory. So when you take a guitar and you go boom with the guitar, and the vibration of the guitar sometimes make the lines disappear. So they're thinking, oh, okay, so this is it. The molecule is here and that and 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 here and that at the same time. So in this theory, we create another theory that is the multiverse theory. What is this? This theory is that it could be a world over there. The Hitler won the war. There was multiple realities happening at the same time. That means, according to this theory, that it could be another Kara living a completely different reality. Have you seen the movie? How is the movie?
Everything, everywhere.
Everything, everywhere.
At the same time.
At the same time. Everything, everywhere at the same time. The movie is boring at the beginning. I couldn't get my eyes. I was just, what is this movie? You know? But then when you start to watch this movie, at the end you go like this, wow. Because the movie describes these probabilities, this reality, that you could be living on different dimensions at the same time, when the past and the future interfere on your present right now. And everything is happening at once. Because when you go to the quantum physics world, time doesn't exist. and it really doesn't exist. Yes, you want to say something?
And sometimes you can feel this another you in another place, something hit you there and get you here. And the same thing, you do something here and they feel there as well.
Exactly. It's all once. This is what the theory is saying. And sometimes they say in the movie that it's very well done, because in the movie it shows the glimpse that sometimes we might have in it, but we don't know what's going on. It's like we go someplace and then we come back here. And it was like, what happened? We think it was a thought, we think it was something else, and it was so strange. Because then what I'm trying to say to you guys is, don't take life so serious. Because you don't even know if this reality that you're living right now.
That is I was thinking. Yeah.
Just leave, because you don't even know what's going on. Okay? Stop wasting your time with little problems, family dramas, things that happens to you in the past that you get so attached. Oh, but when I was a little girl and this happens to me, and all that, bring awareness, receive and let it go. Because according to quantum physics, the present, the past, and the future happens all at once. And something that is happening in the future, and you in the future, can be affecting you in your present life. We know that the past does, but do we know that the future also does that? So this is all possibilities, guys. I'm not saying yes, they know. What I'm saying, those are possibilities. Those are things that we need to start thinking about it. So we don't go, and get entangled with psychological drama, all the time. And I'll let you speak. While it can be intricate and perspective, it also offers immense potential for technology breakthroughs that could shape our future. So I encourage you all to explore this fascinating field further, delve into the mystery of quantum physics, and embrace the wonders of the quantum world. Okay, there is wonderful things to discover, to think about it, to live, to experience. Because if a particle can be here and Andromeda at the same time, that means that there is a possibility for us to travel through space without going anywhere. From here, we can access anything, anywhere. Imagine that.
Would that be how spirits travel?
Who knows?
I'll cancel my trip.
Who knows? And it's so funny because yesterday we were doing a training psychography. We were moving tables here, right? So the table was turning and dancing and going up and going down and dancing around. And then Kardec said, depending on the size of whatever the table or it is, sometimes it's harder or easier to bring them from the floor. And this is the same time with us. So particles are very small, And when you look into a particle, observing the particle, you interfere the particle behavior. But particles are very small. But this means that you can interfere in a lot of things. That means that you can do a lot of things. Because if by observing only, you modify the way a molecule behavior, thinking of what you can do with the cells in your body.
We can heal us.
Thinking of what you can do, oh my God, you can do amazing things. Wonderful things. But because a particle is so small, it's easier to modify. When it's something larger, it will take more access, it will take more awareness to do it. So I'm going to close with the story of the quantum physics world that they tell a story. I did this in my course. If you heard, you're going to hear again. But they say that when Columbus discovered the America in the Caribbean, in the island of the Caribbean, the Indians that were there could not see the ship. The chief saw the effect on water that was on the ship, and he kept telling people, there is something there, there is something there, but he could not see it. But he was so persistent because of the wave that was coming to the shore. He was so persistent, he knew for sure there was something there. He looked, and all of a sudden he saw the ship. And after he saw the ship, he convinced the other ones that there was something that he would describe. He would say, look at that. It's huge. It has this and this and this. And then little by little, one by one, they started seeing the ship. Why they didn't see it? Because they didn't think it was possible. The ship was huge. And how come such a huge ship exists? So your eyes can only see the things that you believe. That means that this is probably why you don't see as many UFO in the sky as you should.
I saw.
Good.
And then
So,
a video.
okay, good. So some people will see it and some people won't. Because if you think that they exist, if you know, it's all about what you think it's possible. What you think it's possible, you can see. What you think it's not possible, you are not going to see it. Even if it's right in front of you. So, thank you so much. It was great, and I see you next time.